Hi Compact Kids, this is the third property that we're learning about exponents, and it's the negative property. So let's pretend we have 2x to the negative fifth power. So whenever you have a negative exponent, that actually means division. And we don't want to write anything as a negative. It's kind of like improper grammar for math. So the correct way to write this would be, we keep the 2, and then this portion right here means divided by x to the positive fifth power. So we would want to write it like this. So basically, whenever you see a negative exponent, we're going to put that down in the denominator because that actually means division. Okay? So let's try a couple more. Let's pretend we have 4 to the negative third power, x to the negative seventh. Okay, so we have two negative powers, so that means dividing by both of these. So we're going to move this to the denominator, and our exponent becomes positive. And we're going to move this to the denominator, and our exponent becomes positive. And then there's nothing left up in the numerator, but we don't want to just put a 0 up there, because a 0 in the numerator of any fraction means the value is 0. So out here, we could take this exact thing right here and multiply it by 1, and it wouldn't change this in any way. So that's what we're going to keep in the numerator. When this moves down and this moves down, this 1 would technically still be up there. So the correct answer for this would be 1 over 4 cubed x to the 7th power. Okay? Let's do 3 to the negative third, x, y to the negative fourth. Okay, so our two negative powers are the ones that are going to move because we're going to be dividing those things. So this one is a positive power because remember, when there's nothing written out here, that implies that there's just one of them. So we're going to keep x in the numerator, and then we're going to move 3 cubed and y to the fourth power in the denominator, and this is the simplified answer to this. Okay, let's combine a couple of rules. Let's combine like the product rule and the quotient rule with the negative rule. Okay, so let's say we have 5x to the fourth over 10x to the negative 8th. Okay, so first things first, we want to reduce the 5 over 10 to 1/2. Okay, and then this x to the fourth is positive, so it's not going to move. It's going to stay up in the numerator. And this one is a negative. So this already means division, and then this negative, it means to it's kind of like a double negative. This is actually going to move up to the numerator. So if you want to just memorize, if you have a negative in the numerator, it actually means division, and it's going to go into the denominator. And then if you have a negative in the denominator, it's going to move up to the numerator. So this x to the negative 8th, we're going to put it up here as a positive 8th. And then with our product rule, remember, this means there's 4 x's here and 8 x's here, which would be a total of 12. So the simplified version of this would be 1x to the 12th over 2. But then 1 we don't really need there because 1 times x to the 12th power doesn't change it. So I'm just going to erase that 1, and our final answer would be x to the 12th power over 2. Okay, let's try it. Let's practice some of these. So if you want to pause the video after I write the problem and try and do it yourself, that would be good practice for you, and then you could unpause to check your answer. So let's say 6x to the negative fourth, y over 15x squared y to the -6. Okay, we have a lot going on right here. The first thing we want to do is reduce the 6 over 15. So 3 goes into both of them. 3 goes into 6 twice. 3 goes into 15 5 times. These negative x's are going to come down here and join those. So I'm just going to kind of do that step in my head, and I'm going to combine them. 4 plus the 2 down here is going to give us 6. And then these -6's are going to move up here and join this one. And there's a 1 right there. So that would be y to the 7th power in the numerator, okay? Let's try some more. Let's do 4x to the 8th times 4x to the -6th. Okay, so I'm combining the product rule and the negative rule. So the first thing we want to do is combine these two 4's. We could either multiply them and write 16, or we could write 4 squared because they mean the same thing. So I'm going to do two different answers, 4 squared, or we could write 16. Okay, so remember with the product rule, you can do it one of two ways, but you could just add these numbers. 8 plus a -6 would give us 2. So we'd have x squared. Or you could think about it like this. 4 times 4 is 16, and then we have 8 x's in the numerator, and those 6 x's would move to the denominator. And then if we wrote all of these out, 1, 2, 3, 4, 5, 6, 7, 8, and we wrote 6 out, 1, 2, 3, 4, 5, 6, and we did canceling, we'd be left with 2 x's in the numerator. So when you get really good at this and you keep practicing, you'll probably just want to go 8 plus -6 is 2. But if that doesn't make sense, you could always move these to the denominator because this means division, and then you could do some cross canceling, okay? So the answer to this one is 4 squared x squared or 16x squared. Okay, let's keep going. Let's do 4x to the -4th over 10y to the -4th. All right, first thing we're going to do is reduce 4/10 to 2/5. And then these negatives are going to move down here. These negatives are going to move up there. So we're going to have 2y to the 4th on top and 5x to the 4th on bottom. Okay. Let's do like 3 more examples. 6x to the -4th y. So this one's just the negative rule, not product or quotient going on, but this is going to need to move. So the answer would be 6y over x to the 4th. And that would be your final answer. When you're doing these, just make sure your final answer does not have any negative exponents in them. We do not want negative exponents in our answers. It's kind of just grammatically wrong in math. So let's do one that's on your paper. 6u to the -1st power b cubed. I'm doing problem number 26 over 3u to the 4th b to the 4th. Okay, so we're combining the quotient rule with the negative rule. So first thing, we want to reduce 6 over 3 to 2 or 2 over 1. I'm just going to write 2. And then these negatives are going to move down here and combine with those. So we're going to have u to the 5th on the bottom in the denominator. And then these ones, we're going to need to cancel out. So remember, cubed, that means there's 3 V's up top. 1, 2, 3, and there's 4 down below. 1, 2, 3, 4. Cancel, cancel, cancel. And we're left with 2 over u to the 5th V. You could also think about the quotient property as 3 minus 4 would give you -1, but we never want a negative, so we're going to put it as a +1 in the denominator. Okay, I'm going to do one more for you. Let's do another one on your paper. Let's do, oh, it looks difficult. Let's do the last one, problem number 30. So we have 4x y to the -1st over 5x to the -4th y cubed. Whew. Okay, so first we want to reduce 4 over 5, which you can't. So I'm just going to rewrite it, 4/5. Okay, this x is fine, it's a positive, but these ones are negative, so those ones are going to come up here and join those, which is going to give us x to the 5th power, because 4 plus the 1 would give us 5. And then these y's are going to move down here and combine with those y's, and we're going to have y to the 4th. I don't have any negative exponents in my answer. If this is confusing, which I know it's a lot of information at once, please join my Google Hangout on Tuesday and we can practice problems together, or I can answer any questions that you may have. And then I will attach this worksheet practice paper along with the answer key so you can grade yourself.